All right, welcome back to The Explainer. This is where we take data and turn it into a story. And today, today we're putting on our detective hats.
So let's say you've got a job. You've been handed over 6,500 photos of farm animals, just a huge, messy pile of them. And your task, teach an AI to see exactly what's in every single picture. How in the world do you even start?
Well, here's the thing. Before you even think about building that AI, you have to play detective. Yep, you heard me. You have to investigate your data first, because just like in any great mystery, all the clues, and trust me, all the potential problems are hiding right there in plain sight.
So, our investigation kicks off with the first most basic step. We've got to collect all the digital evidence. It's time to turn all this chaos into some actual clues we can work with.
Now, in the data science world, this whole process has a fancy name, Exploratory Data Analysis, or just EDA for short. But really, you can just think of it like a detective's first sweep of a crime scene, you know? We're not trying to nail a suspect just yet. We're just getting the lay of the land, figuring out what we're even dealing with, and keeping an eye out for anything weird.
Okay, so our digital forensics process is pretty straightforward. It's a three-step plan. First, we got to scan all the directories and find every single one of those 6,570 image files. Then, step 2, we match each image to its label file. That's the little file that tells us what animal is in the photo and exactly where. And finally, we pull it all together into one big master evidence table.
And boom, here it is. This is our master evidence log. This is how we take that digital mess and bring some order to it. See, every single row here represents one animal we found. It's got the image path, a class ID, which is just a number for the animal type, like 3 for a horse or 2 for a sheep, and it even has the coordinates for where that animal is in the picture. This table, this is the bedrock of our whole investigation.
And get this, across all those thousands of images, we didn't just find a handful of clues. We found 22,342. That's 22,342 individual clues or annotations. That is a ton of evidence for our detective to sift through.
Okay, so our evidence log is looking good. Now we can move on to the really fun part, profiling the suspects. This is where we're going to find the first big break in the case.
Right. The evidence is all neatly organized. Let the profiling begin. So, who exactly are the main players in this little drama?
A quick lineup gives us our 4 main classes. We've got cows, pigs, sheep, and horses. But the second you look at this chart, a detective's eye immediately spots something, well, something's not right. Look at that. One of these things is definitely not like the others, not by a long shot.
And just like that, we've hit our first major discovery. This case is completely flooded with one particular suspect. It's not a balanced investigation at all.
I mean, look at the tail of the tape here. We have 12,388 instances of sheep and only 545 instances of pigs. Let that sink in. That is a huge imbalance. We're talking more than 20 times more sheep than pigs. Wow.
So why does this matter so much? Why is this such a big deal? Well, think about it. An AI learns from what you show it. If you feed it a diet that's almost all sheep, it's going to become an absolute expert on sheep. But when it sees a pig out in the wild, it might have no idea what it's looking at because it's barely seen any. This isn't just a small issue. It's a critical flaw in our evidence.
All right, so we know who the main suspects are. The next logical question for any detective is, where? Where are all these clues hiding? It's time to map the hotspots.
And check this out. This heat map is basically our crime map. It shows us where the animals typically appear in the photos. The bright yellow spots, those are the hot spots. And, I mean, you don't have to be a detective to see the pattern here. It is screamingly obvious.
The evidence is just overwhelming. Our subjects aren't off in the corners or hiding at the edges. Nope, they are almost always found smack dab in the center of the frame.
And if you don't believe the map, just look at the photographic evidence. A quick review of the actual pictures confirms it. The photographers weren't just snapping random shots. They were consistently putting the animals front and center. This tells us something important. The framing is deliberate.
Okay, let's recap. We've collected the digital evidence, we've profiled our suspects, and we've mapped all the hotspots. Now it's time to crack this case wide open and write up the final report.
So first up in the report is the dataset split. You've got your train set, that's the big one we use to teach the AI. Then you have validation and test sets, which are basically like pop quizzes to make sure it's learning. But look at that last column. What's really interesting is that on average, each image has about 3 to 4 animals in it. That's pretty consistent across the board.
And this next table, this just drives home our biggest finding. That huge imbalance we found, it wasn't a fluke. It's in every single part of the dataset. I mean, look at the training split. Over 9,000 sheep, but only 450 pigs. That bias is literally baked into the DNA of this dataset.
So, the detective's final findings are in. Let's lay them out. Number 1, the dataset is just massively, heavily biased towards sheep. Number 2, pigs are critically underrepresented, almost an afterthought. 3, almost all the animals are well-framed, right in the center. And 4, on average, you're going to find about 3 to 4 animals in any given picture.
And that's it. The investigation is officially closed. The detective's report is on your desk. You know the data's biased. You know it's flawed. So the final question isn't for me, it's for you. You're the AI builder now. Knowing what you know, what's your first move?